integration theory in your 12th standard. If I am interested to find out the area under the curve, this is the area under the curve. If I wish to study this, so how will you study this area under the curve? You are simply dividing this particular area into this small strip. They are nothing but they are the some rectangulars. Okay, and then you make the find out the area of this strip, area of this strip, and then the sum of all strip. It is giving the area under the curve. Of course, when you are finding the area under the curve, you are not able to get exact information because to find out this particular area of this strip, okay, you will use the concept of some upper sum and lower sum. And by using this upper sum and lower sum, you will find out the area on the curve. In integration, the concept is known as the Riemann integration. Okay, so variable may be of a two type. One is of a discrete, and another is of a continuous. So variable means it takes some different value. It takes different value. If it takes the integer value, let us say 0, 1, 2, then such are said to be a discrete random variable. Discrete variable, not random, discrete variable. And if it takes the value lies between, let us say x is some variable which is either discrete or continuous. If it is a discrete, it takes value 0, 1, 2, likewise. It may be of a finite integer or infinite integer. And if it is a continuous, it is lies between on the minus infinity to infinity, or you can say that it belongs to the real line. These all are said to be variable. Variable means it takes a different value. But we say that random variable. So what do you mean by the, let us say x is a random variable? It means the variable x take different value with some probability low. X takes different values with some probability low. Or you can say that when x follows the certain distribution. So when you say that the probability low, it means certain probability distribution is associated with this. Suppose if you are talking about the tossing of a coin, okay, then x is a event that head occurs. So when x takes is head occurs, that means x takes value either tail or head. Event is that head occurs. So x takes value tail as well as the head, because when you tossing the coin, there are two possible outcomes: either tail appears or the head appears. Okay, if I am saying that tail means if head is appears, we say that h is equal to 1, and if tail appears, that means there is no presence of head, so we say that x takes two values 0 and 1. So this is an example of classical example of the tossing of a coin. Now we say that when what is the probability that the x takes value small x? Small x means it is x, it is a value, and capital X is nothing but it is a random variable. So random variable takes value let us say x equal to 0. That means it is a probability that the tail occurs. So how many possible events? Events are 2 in a simple space. You say that, let us say this is the simple space. So simple space omega having a 2 outcomes. Okay. So you can say that it is a 2. And how many favorable events are there? So head appears. That means the number of events appears. So head appears only once. So what is the probability that? The probability of the occurrence of the tail is also half, and probability of occurrence of the head is also a half. So this is said to be a probability of success. And that is the half. So we know that the sum of the probability is 1. So probability of x equal to 1 is equal to probability of, or plus x equal to 0 is equal to 1. Okay. So this is nothing but probability of success is half, and probability of failure is also half. The sum is 1. So sometimes we call them the probability of success is a P and probability of failure is a Q. So if we can calculate the P, you can easily calculate the probability of failure by using this formulation. So it means that what is the distribution of x? You say that x takes value 0 and 1. And what is the probability? X takes value x, that is the, it is when it takes 0, it is the half, and when it takes, it is the half. So something like that you have studied in your BSc level, the starting of the probability theory. And if I'm writing this in this form, probability of x equal to x is equal to half raised to x and half raised to 1 minus x. X takes value 0 and 1. So if I'm substitute x equal to 0, what will you get? X equal to 0, what will you get?
1 by
1
2.
by 2.
1 by 2 power
Yes.
0, 1 by 2
Power.
power 1 minus 0. So this is nothing but 1 by 2, anything raised to 0 is 1,
1
and
into
this is
1
1
by
by
2.
2 raised to 1 means 1 by 2. So that is 1 by 2. And that you can observe half. Similarly, x takes value 1, 1 by 2, x takes value 1, that means you have to substitute x equal to 1. So this is 1 by 2 power 1 minus 1. So it is again a 1 by 2. So what happened? I have done nothing. I have just write in the some mathematical form. So it is a, this nothing but the probability mass function. And it is a probability mass function because if the trial is said to be a Bernoulli trial. In Bernoulli trial, we say that the probability of success remain the constant at each trial. Okay, then we write this in this structure. Instead of the p equal to half, we say that p raised to x equal to q raised to 1 minus x equal to 0 and 1. Okay, and p is lies between 0 to 1. Okay, and p plus q equal to 1. Then this equation is known as a Bernoulli distribution. So Bernoulli has given the concept of this distribution, and therefore the distribution is known as a Bernoulli distribution. Now you can use, maybe the probability of success may be vary from example to example. If a tossing of coin, it is we say that there is equally likely. That means the probability of success and the probability of failure is same. This is the probability of failure, this is the probability of success. So they are said to be equally likely event. Whenever the each event has the same probability, then events are said to be equally likely. We've also seen the concept of a mutually exclusive. If we say that the event A and B are said to be mutually exclusive, if intersection A intersection B is phi, if we say that event A and B are exhaustive, when A union B is equal to U, or you can say that omega In our case, we have certain it is omega. Okay, so this is nothing but the sample space. This is said to be a null event. And what is the probability of A intersection B? It is the probability of phi is equal to 0, and probability of A union B is nothing but probability of omega is equal to 1. In our case, A is nothing but head up, head occurs, and B is nothing but tail occurs. Why I have written this? Because there is no connection between the head and tail. Okay, so they are non-overlapping. They are mutually exclusive, and that is how the probability of the head and tail together occur is always 0. It is not the kind of that key head and tails both events appear together when you flip a coin once upon a time. And the exhaustive event that all the possible events. So what are the outcomes? Possible outcomes are maybe head or maybe tail. All possible outcomes is nothing but in the form of the sample space, and when you find out the probability of sample space, it is giving the 1. So something like you have studied in the uh, BSc level, and then you say that let x1, x2, xn are nothing but follow the Bernoulli with probability P. P is the probability of success, and each trial, the probability of success remain the constant. Then, and the trials are n, then the T is equal to, or other things, I equal to 1 to n xi is nothing but binomial with n and p. N is nothing but the number of trials, and p is remain the probability of success. So when x1, x2, xn are Bernoulli trials with the probability of success remain the same at each trial, then the sum of the Bernoulli distribution, or the sum of the Bernoulli trials having the binomial distribution. And the PMF of the binomial distribution is written as this: NCX p raised to x q raised to n minus x. X takes value 0, 1, 2 up to n, and p is lies between 0 to 1, and p plus q is nothing but 1. So this is said to be a Bernoulli, binomial distribution. It's a probability mass function for a binomial distribution. So that is how. And when you talk about the distribution, if this is about the discrete distribution, then you have talk about the continuous distribution. You have also talk about the distribution of count, that let us say x having the Poisson distribution with parameters lambda, if its PMF is given by, it is nothing but e raised to minus lambda, lambda raised to x upon x factorial. X takes value 0, 1 up to infinity, and lambda is always greater than 0. Why lambda is greater than 0? Because x is nothing but the count, and when you find out the expected count, it can not be negative, it is always non-negative. Okay, so this is said to be a Poisson distribution. Similarly, as I say that there are two types of variable, one is a discrete, another is a continuous. So discrete having the integer, or you can have the count. So it may have the Bernoulli distribution, it may have the binomial distribution, it may have a Poisson distribution. You must have also studied the uh, hypergeometric distribution. You have studied the geometric distribution. You have studied the negative binomial distributions. Okay, you have studied that. Okay, suppose you are making the trials. In the first trial, you are getting the failure. In the second trials, you are making the failures, but you are continuing the trials till the last trial must be success. So it is kind of that p raised to x equal to x, q raised to x, p, where x takes value 0, 1 up to infinite, because trials are infinite. When you will stop the trial? When the last trial must be success. So this is nothing but the PMF of a geometric distribution. For example, in industrial process, You are trying to see that when the production process is going to stop, when there is a defect is observed. So in our setup, what is the success? Success is not the non-defective item. Success is defective item because we are associated with the quality assurance. So as soon as we observe the defect, we have to stop the production, and we have to rectify why there is a defect is present in the production process. So we continue, and when we stop, when we get the defect. So such kind of the study in the SQC, statistical quality control, follow the geometric distribution. Am I audible to everyone?
Yes, sir.
Yes, sir.
ओके. बीच
Yes,
बीच
sir.
में आपको बोलते रहना पड़ेगा क्योंकि मुझे आपके फेस नहीं दिखते हैं. आप क्या कर रहे हैं आई डोंट नो.
Okay, sir.
मुझे सिर्फ
Okay,
मेरी
sir.
स्क्रीन दिखती है. ठीक है.
Okay, sir.
और दूसरा ये है कि इन दी मीन वाइल यू हैव टू ऑल्सो मेक द राइट अप. ओके. बिकॉज इट इज नॉट लाइक दैट कि मैं आपको पूरा 100% मटेरियल दे दूंगा. आपको जो जो यहाँ पे लिख रहा हूँ वो आपको साथ साथ में लिखते रहना भी है, आपको जहाँ पे लगे हो. ठीक है. ओके. आगे बढ़ते हैं. We know that the sum of the geometric distribution. What is the sum of this geometric trials? It is nothing but hypergeometric. Okay, and hypergeometric distribution has the specific application. Suppose if I wish to measure or I wish to identify how many number of fishes are in the pond. Okay, count of fishes in pond. So which has the hypergeometric distribution that you studied in your BSc level. So that means the sum of the geometric trials having the hypergeometric, similarly to the sum of the Bernoulli trials having the binomial. So herely some of the geometric trials have the hypergeometric distributions. Then you have a negative binomial. Sometimes it is also known as a Pascal distribution. Okay. So what is the use of negative binomial? Negative binomial distribution is also known as a Pascal distribution. It is also known as the inverse binomial. See, whenever you are giving the net or set examination, such kind of the questions are there. If you try to relate each and every distribution with each other based on the certain property, so it is very easy to clear the such competitive examination. So inverse distribution or inverse binomial or negative binomial or Pascal distribution. Why it is inverse binomial? Because it is inverse to the binomial. In which sense? In binomial trial, what happened? Out of n, we try to identify how many successes we have. Okay. So that means the number of trials are in our hand. And then when we do the experiment and then try to identify how many success we observe. That is the concept of a binomial trial. But in negative binomial or inverse binomial, we know that the number of successes on our hand. And to achieve this many success, how many trials we have to conduct. And whenever you wish to such kind of a models, then we have to go for the negative binomial or inverse binomial. Especially in the survey sampling, it has a lot of application. Where we know that we wish to achieve this many of the success. Now to obtain this many of the success or to obtain the proportion of the success, okay, how many trials or how many respondents we need to observe, we need to study. So that can be identified through the inverse binomial or the negative binomial distribution. In binomial, we have n is given and we try to find out what is the probability of success or the event of success. And here we have given the success. Success is given and we try to identify how many number of trials are required to achieve these many successes. So this is nothing but the negative binomial distribution. Okay. Similarly, when you say that when you talk about the continuous variable, let us say x is a random variable which has some continuous distribution, if its PDF is given by fx. And the distribution function, when you say about the distribution function, it is nothing but the cumulative. It is known as a cumulative distribution function. That means you are trying to find out what is the probability that x is less than or equal to x. It can, we are calculating in the both the case whether it is a discrete or whether it is a continuous. So we have studied the standard norm, we have studied the distribution. X follows the exponential with lambda or theta, okay, whose mean is theta. Then the fx theta is given by 1 upon theta e raised to minus x by theta, and x is greater than 0 and theta is also greater than 0. Then x is said to have a exponential distribution. And when you make the plot of exponential distribution, the graph is something like that. So whenever you have the data and if you find out the distribution or the histogram, the graph of the histogram or the graph of the data is something like that, then it must be exponentially distributed. That means the variables follow the exponential distribution. Why we are looking for all distribution study? Because ultimately our basic idea is that to study distribution, means to identify patterns in the data. Or to study behavior, study behavior of data. For example, let me give you the example. In our MSc, we have a project. At final semester, we are offering projects to all of you, and everyone has to do the compulsory MSc project. So we have taken the project of the automated teller machine. We know we call them as a ATM. Whenever we require the money, anytime we can withdraw money from the ATM. So now the question is that how much amount of money how much amount of the money एक मिनट चालू रखिए ये अक्षय अक्षय आपके क्लास में है हेलो
सर पता नहीं है सबका इंट्रोडक्शन अभी तक इतना हुआ नहीं
तो मुझे ही करवाना पड़ेगा ऐसा लग रहा है
नहीं
तो वो बोल रहा है लिंक उसको मिला नहीं है हमें कैसे पता चलेगा ठीक है उसको लिंक भेज देता हूँ ओके सो द माय क्वेश्चन इज दैट how much amount of the money should I keep into ATM machine? Okay, the money should keep in ATM. Now, can anyone tell me how to proceed? This is the question is raised by the bank. We have so many ATM machine. Now, can you suggest me that how much amount of the money should keep in the ATM so that no customer complain? आप सबने एटीएम से पैसे विड्रॉ किए कभी?
हाँ सर
किए हैं
Yes,
ना?
sir.
तो आपको पता होना चाहिए। वी ऑल आर स्टैटिस्टिशियन। हम सिर्फ जाके एटीएम में पैसे कार्ड एंटर किया एंड देन वी हैव जस्ट आस्क्ड फॉर द ट्रांजैक्शन, एटीएम हैज गिवन द मनी।
Twenty 20,000 है अभी से
Hmm?
20,000 या 25,000 कुछ।
No, that is the maximum limit. You can withdraw the 25,000. This is the maximum. See, why
Like
distribution
how much
clearing is
money
so
we should
important.
keep? The question is how much money we should keep in the ATM so it will be convenient for the customers, right?
Yes, exactly.
So
So as a bank, I am interested कि भाई how much amount of the money I should keep. Should I keep 5 lakh, 10 lakh, 15 lakh, 20 lakh, crores? How much?
How
uh,
much the customer can afford?
no, should like we should calculate the frequency of customers coming visiting the ATM, so we can calculate with that like how much customers are withdrawing. We can get the data regarding that first.
So, Shruti, na? Shruti,
Jyoti.
Jyoti, okay. So, as per the Jyoti, she said that we should have the data that the how many customers are visiting the specific ATM machine and how much amount of the transaction each customer is making during the each transaction. Is it, Jyoti?
Yes, sir.
Okay,
So we can get approximation.
okay. Um, Suppose this data is available to you. It is given that, let us say that there is a, when you come to the Vidyanagar, there is one location, that is location 1 in the Vallabh Vidyanagar, and every day 100 customers are visiting the ATM machine and the transactions are given. So suppose the data of a, let us say 1 year is given to you. Suppose a Dr. Raykundaliya is visiting the ATM machine and at each transaction he will do the transaction and the transaction amount is, let us say, 10,000. Jyoti and Tony is visiting that the same ATM machine and the transaction amount is, let us say, 2,000. Then Rutvik is visiting, Shruti is visiting, Shraddha is visiting. So likewise, let us say the every day, let us say the 100 customers are visiting and there the amount of the withdrawal is given to us, and such information is given for a 1 year. That means 365 days data is available to you. The It may not be necessary that same customer is repeating. Okay,
Right.
every day same customer is not repeating, the customers may be the different, but let us say that the 100 customers have visited the ATM every day and their amount of withdrawal is given, and that such data is given of a 365 days. That detail is available with the bank because nowadays everything is recorded with the time. Especially time is also given. At what time the customer is visiting, what is the peak time, where there is a heavy queue, in which time there is a maximum about the withdrawals, etc. Now, how as a statistician, as a person like a expert of a distribution theory can help the bank? As I say that this is not a one-way communication. I must appreciate if there is a discussion among you and me. Yes, Rutvik Wagadia.
No idea, sir.
No idea. Good. Rahul,
No idea, sir.
Gaurav, Sweetie,
No idea, sir.
No idea? Anyone?
No, sir.
Okay. So suppose if this data is given, what I can find out? I can find out the average transaction per day. Suppose 100 customers are with me, and I can find out the average transaction per day. Suppose total volume is, let us say people have withdrawn the 5 lakh rupees total cumulative for a per day, 100 customer. So 5 lakh divided by 100. What is that figure? 5,000. Okay. So every transaction, that means on average, when the customer is visiting the ATM, they are withdrawing 5,000 per day. Okay. So that means I can have this transaction. Now I can make the plot of this data. How many such average value is with 365 days? So I can make the histogram, and based on the histogram, I can take the decision whether the distribution is a positive skewed or negative skewed.
Right.
अब ठीक है. अब ये इसमें डेटा में तो none of the observation is negative because transaction negative तो होगा नहीं. So that means it is a positive
Positively
valued
skewed.
random variable. So what are
Right.
the continuous distribution uh, which are the positive valued random variable? So you can have the exponential distribution, you can have the gamma distribution, you can have the Weibull distribution, you can have the Pareto distribution, you can have a log normal distribution. There's many distribution you have studied in BSc level. Okay. Now, once this particular information with me, what I do, as I said that I will make the histogram, or you can say that the density curve. And suppose the density curve is something like that. So which distribution has this kind of a curve? So we should know this. See, as a distribution study, हमने mathematically study किया है. We should not only look for the formulas. We should have the what is the shape of the distribution, what is the scale associated with that, what is the nature, whether it is a positive skewed, whether it is a negative skewed, whether it is a symmetric. This all the things we should keep in our mind, because in real life you should only get the data. Nobody will say that okay, my random variable x follows the gamma distribution. Now let me help you. You have to first identify whether your random variable x has the gamma distribution or not. And what is here x? X is nothing but average amount of transaction per day. So x is your, and how many such figures is given? X1, x2, x30, 365. Okay. So you can have the data of a 1 year because ATM is not closed on Saturday and Sunday. Okay, that is how we have the information of every day. Now we have to first make the histogram. To identify the nature of the distribution, we find out the summary measures. What are the summary measures we will calculate usually? We will calculate mean, median,
Meet.
mode, what is the minimum transaction, what is the maximum transaction, what is the standard deviation associated with that. Okay, that means how much variance is available. Based on that, you know that the relation between the mean, median, mode. If mean, median, mode are same, then you say that it is a symmetric distribution. If mean is greater than mode, sorry, median, then the mean or mode, then you said it is a positive skew. If mode is less than the median, less than the mean, then it is a negative skew, something like that. So you know that this relation, based on that you can identify whether the positive skewed or negative skewed. Second, you can draw the graphical summary. In graphical summary, you have to see that whether your data is continuous or discrete. If it is a discrete, then you can make the bar chart and pie chart. Okay, but in our setup, the data is a continuous because we don't know that what amount of the money they are going to. It is from the 0 to infinity. Okay, so the data is a continuous, so we can make the either box plot, we can make the histogram, okay, or normal probability plot. These are all things you have studied at your BSc level. Okay, and based on that you take the decision. Box plot you must have studied something like that. Okay, this is your Q2, this is your Q1, this is your Q3. With the first quartile, second quartile, and third quartile. Q2 is nothing but the median. If the median divide the area in box into the two equal part, then we say that the data comes from a symmetric distribution. And again, based on the relation between the, this is nothing but it is known as a whisker. And the range of the whisker is 1 point. क्या है वो 1.5 times Q3 minus Q1. Q3 minus Q1 is known as the interquartile range. It is known as the IQR. सी जब आप इंडस्ट्री में जाएंगे तो ये सारी चीजें इक्वली इंपॉर्टेंट है. यू शुड नो दैट. Okay, because the data are given to you. Even as a statistician, if I wish to conduct the research, so in real life the problems are given to me. I have to convert this problem into the mathematical or statistical form, and then I can apply all my theories like distribution theory, estimation, testing, others, modelings, and etc. etc. But you have to first understand the nature of the data. So based on that, you can take whether your data is symmetric or not. So symmetric has the histogram is something like that. This is the symmetric. This is the positive skewed. This is a negative skewed. Okay, so this is symmetric, positive skewed, and negative skewed. So once you have the histogram, you can have the things in mind which are the distribution available in literature has the positive skewed distribution, which are the member of positive skewed class, negative skewed class, symmetric. In symmetric, we know that what are the distribution symmetric? It is a normal,
Normal.
then T, Cauchy, है ना ये सारे normal distribution, T distribution, Cauchy distributions are symmetric. Positive skewed में you have a exponential, you have a gamma, you have a Vibul, chi-square, F, Pearson family, etc. So you have the various positive skewed random variable distributions are there. You have also extreme values are distribution. When there is a long tail present in your data, there may be extreme values. Extreme means some outliers are present in your data. So based on that, you have to first identify, and after identifying, you have to calculate the estimate of the parameters of a distribution. So how to estimate the parameters? What are the different methods are available? So you may have studied the method of moment, method of maximum likelihood, least square estimators, other. So several methods are there. So Patel sir will explain you the various methods, and then we have to see that whether the what are the properties of that estimators, whether it is a consistent, whether it is unbiased, whether it is a sufficient, whether it is a minimal sufficient, whether it is a complete, etc., etc. So that you will be study as a separate in the estimation part. But again, I will come back to that. Once it is identified that the amount of the money, okay, my question is that I wish to identify how much amount of the money should keep into the ATM machine. So it is identified that the per day transactions, average transaction value has the, let us say, Weibull distribution. In my study, it was a Weibull distribution. So I have fitted the Weibull distributions. Once the Weibull distribution is my hand, what is the, suppose the form of some Weibull distribution is something like that. Beta raised to alpha upon gamma alpha x raised to alpha minus 1 e raised to minus beta x. Okay, something like that, where x is greater than 0, alpha and beta both are greater than 0. Alpha is said to be a shape parameters. This is a shape. And beta is said to be a scale parameter. So this is not equal to probability of x, or you can say that fx. It is a density function. Okay, so that means I need to estimate the alpha and beta. If I know the value of alpha and beta, I can obtain this probability. And once I have this probability, then I can find out the 95% confidence interval for the average transaction. I can find out the maximum transaction. So that based on that 95% transaction, if I observe that only with 95% confidence, I am saying that the 2 lakh rupees is sufficient to keep into the ATM machine, then should I need to keep 15 lakh rupees? Because every ATM has limit that they can keep maximum 15 lakh rupees. But I have studied a specific ATM machine, and it is saying that with 95% confidence interval, if we keep the 2 lakh money into the ATM machine per day, okay, then there should not be any trouble. There should not be any trouble, or there should not be any issue with the customer that there are no money at the ATM. So if I have this 2 lakh rupees in ATM, and earlier I said that I have to keep 15 lakh rupees. So what happened? What is the margin? Margin is a 13 lakh rupees. That means you do not require to keep 13 lakh rupees additional into the your ATM, because 2 lakhs are sufficient with 95% confidence interval. Why you can say? Because you have fitted the probability distribution. You have studied the patterns of withdrawal, the average amount of the transaction that you have model, and it has the Weibull distribution. So you have identified the behavior of the transaction using this. So what you say, that with 95% confidence interval, if we keep the average amount of the money 2 lakh per day into the ATM machine, there should not be any customer complaint, or you can say that hassle-free transactions are there. So suppose if you keep 2 lakh rupees, so how much money is ideally is with you? 13 lakh. So you can lend this money to some customer and you can earn the interest. This is about the one ATM. Suppose the same branch has the 5 ATM machine in the same. Okay. If you have suppose the 5 ATM machines into the same city, then you can see that how much amount of the money, 65 lakhs you have additional. And if you simply give this particular to the customers at the rate of 9% at the every year, then you can see that how much interest you can earn. Are you getting my point?
Yes, sir.
Yes, sir.
See, so this is the beauty of a statistics and beauty of a distribution theory. Whenever you have the data is with you, you try to always see that what is the patterns available in the data. Are we in that position to forecast this pattern? Are we in that position to model this pattern? If we can models, we can have some idea, and based on that we can take the decision. And that decision is a scientifically. It is not like that आज मेरे मन में हुआ मैंने 10 लाख रख दिया, कल मैं 5 लाख रखूंगा, आज 3 लाख रखेंगे. No. So similarly in the stock market, you can have the price of the share, and then you try to identify what is the price movement and what is the return of a share every day you are getting. Then you can model the returns, and based on that patterns you can try to identify what is the average or expected returns. If you associate it with the time data, then it is a time series analysis. So what I mean to tell you that whenever the data is come to you, you have to always try to identify what kind of the distribution it has. So I have just given the one example of a ATM machine. I hope it is helpful to you to understand what is the application of the distribution theory. So if you have the data, let us X has the normal distribution. X follows the normal distribution with mean mu and variance sigma square. This is generally we say that it is a standard distribution if its PDF is given by 1 upon root 2 pi sigma e raised to minus half x minus mu upon sigma whole square. Okay, and here the range of x is nothing but minus infinity infinity, because x is minus infinity infinity. Of course, mu is also lies between that, and sigma square is always greater than 0. And we say that the mean of the normal distribution is mu and variance is nothing but the sigma square. And to know any distribution, we should know its first two moments. If you know the first two moments, you can easily characterize the distribution, or you can easily identify the distribution. For example, if you say that the data is a discrete and the mean is greater than the variance, so this is the example of a binomial distribution. Say data is a discrete and mean is equal to variance, then it is a example of a Poisson distribution.
Poisson distribution.
Similarly, in a continuous, you can have the mean is greater than variance if lambda is greater than 1, then it is a example of a exponential distribution. Likewise, you can identify the based on the nature of the mean and variance relation between the mean and variance. You can also characterize the distribution. It is giving the rough idea. Then you have to verify. How to verify? Once it is identified that by using the histogram or by using the summary statistics, it is saying that the data may follow the exponential distribution or binomial distribution or chi-square distribution, then you have to perform the goodness of fit test. So whether the data follows the specific distribution or not. So you must have studied the two types of goodness of fit test. One is a Kolmogorov-Minro test, and second one is a chi-square goodness of fit test. Okay. So then you can statistically prove whether the data follows really this distribution or not at last. Okay. So these are all the basics of distribution which you have studied in the BSc level that I have given. Any questions so far? Anyone?
No, sir.
Sir, can you give an idea again about Weibull distribution, because it is something new that we haven't done in a BSc.
आवाज कम आ रही है. Hello.
Yes, sir.
Hello. Am I audible?
Hello. Yes, sir.
हाँ बोलिए क्या बता रहे हैं?
सर वेबुल डिस्ट्रीब्यूशन के बारे में एक और बार बताइए ना, लाइक वो कहाँ यूज होगा उसका, वो सारी चीजें, क्योंकि वो बीएससी में नहीं आया था तो ये पहली बार आया इसलिए.
नहीं वो एमएससी में भी नहीं आएगा, डोंट वरी.
अच्छा.
एमएससी में सपोज वेबुल डिस्ट्रीब्यूशन आप पढ़ेंगे तो यू विल स्टडी इन द रिलायबिलिटी सेटअप. कि थर्ड सेमेस्टर में जाएंगे तब आपको रिलायबिलिटी में आपको पढ़ाएंगे. वहाँ पे
ओके.
आपको बेसिक डिस्ट्रीब्यूशन, वेबुल डिस्ट्रीब्यूशन क्या है, उसके एप्लीकेशंस क्या है, वो सब बताएंगे. स्पेशली वेबुल is a physicist, and he has given the concept of distribution by studying the wear and tear of data. जैसे आपने आयन है उसको रखा है सपोज ह्यूमिडिटी एनवायरनमेंट में, तो उसमें जो कोरोजन हो रहा है, तो कोरोजन का जो डिस्ट्रीब्यूशन है इट हैज फॉलो द वेबुल डिस्ट्रीब्यूशन. एंड वेयर एंड टेयर की बात आ रही है तो इट इज एसोसिएटेड विद द रिलायबिलिटी स्टडीज. ओके, तो इन रिलायबिलिटीज वेबुल डिस्ट्रीब्यूशन हैज द लॉट्स ऑफ एप्लीकेशन, but it has been introduced in the reliability setup, wear and tear study, Even for example, if you talk about the human being, so what is the mortality rate of the infant? इन्फेंट मतलब नया बच्चा जिसका जन्म
हाँ
हुआ, ठीक है, तो व्हाट इज द मोर्टालिटी रेट? द मोर्टालिटी रेट इज हाई। ओके, जैसे 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 एज बढ़ती जाएगी तो मोर्टालिटी रेट क्या हो जाएगा? कम होगा ना, बच्चा
कम
बड़ा
होगा।
होता है तो
हाँ
रिस्क वॉज रिड्यूसिंग। फिर आप सबकी एज में, यंग एज में रिस्क इज कांस्टेंट, और जैसे
हम्म,
जैसे एज बढ़ेगी तो क्या होगी? मोर्टालिटी रेट बढ़ जाएंगे। तो ये आप देखो, इसका कर्व कैसा है? बाथ टब, बाथ टब होता है ना अपने घर
हाँ
में,
हाँ।
उसके
हम्म,
जैसा है। तो Weibull distribution has the bathtub curve property. That means the if you find out their hazard rate, or you can say that instant failure rate. So as initial stage, the any product has the higher failure rate. जैसे 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 इसका इस्तेमाल होता जाएगा, धीरे धीरे उसका फेलियर रेट क्या होगा? कम होगा। एट सर्टन टाइम इट बिकम द फेलियर रेट इज कांस्टेंट, एंड जैसे जैसे उसकी उम्र ज्यादा हो जाएगी, द फेलियर रेट इज इंक्रीजिंग। So if you talk about the live being or a human being, then it has the Weibull distribution. If you talk about the bulb, initial there is a high chance of failure of a bulb. Slowly and slowly जैसे आप उसको यूज करते जाएंगे, उसके फेलियर के चांसेस कब होंगे? सर्टेन पीरियड उसका फेलियर रेट कांस्टेंट होगा, लेकिन एक लाइफ हो जाएगी तो बल्ब के फेलियर रेट होने के चांसेस क्या हो जाएंगे? बढ़ जाएंगे। तो
बढ़
दे
जाए।
विल डिसाइड द वारंटी पीरियड कि प्रोडक्ट की वारंटी कैसे देनी चाहिए। तो इट इज बेस्ड ऑन दैट फेलियर रेट। What is the expected failure rate? So how will you identify? So first you have the experimental data is in your hand कि भाई आपने बल्ब को रखा, तो आपने ऑब्जर्व किया कि भाई वो कितना, पहले बल्ब का कितना सर्वाइवल टाइम है, दूसरे का कितना है, तीसरे का कितना है। लाइकवाइज यू ऑब्जर्व एट व्हाट टाइम द बल्ब इज फेल्ड, and that time, let us say first bulb is failed at the T1 time, second bulb is failed at T2 time. Likewise you have an observation. So that observation is nothing but failure time of first bulb, failure time of second, and failure time of the nth bulb. And you are trying to identify what is the distribution of this. And suppose if it has the Weibull distribution, then you can have the several properties. Okay, what is the expected time to failure? So expected time to failure, that means that is giving the warranty period. मैक्सिमम टाइम ऑफ फेलियर कितना है, तो कितने और तक आप उसको वारंटी एक्सटेंड कर सकते हैं। तो these are all basic things can be decided based on the distribution, and distribution is a very important part of statistics, and whenever you come to the reliability theory you will study in detail. Okay,
ओके सर।
any other questions? Anyone?
सर आई हैड अ लिटिल डाउट।
Yeah.
तो सर जैसे आपने ऊपर एटीएम वाले उसमें एग्जांपल दिया, तो मैं ये पूछना चाहता कि उसमें फॉर एग्जांपल हम 365 डेज का डेटा लेना चाहते हैं, लेकिन रियल लाइफ में तो ये पॉसिबल नहीं होगा, क्योंकि 365 डेज तो वो चालू नहीं होगा, ट्रांजैक्शन नहीं हुआ होगा, क्योंकि कभी कोई मेंटेनेंस का ब्रेक होगा, या फिर किसी वजह से उसमें करेंसी ख़त्म हो गया होगा। तो उस दिन का तो हम क्योंकि कस्टमर का ले रहे हैं एवरेज 100 कस्टमर्स का, तो उसमें वो एवरेज में डाइल्यूट हो जाएगा, वो ज़ीरो जो ट्रांजैक्शन नहीं हुआ है। लेकिन जब हम उसका टोटल एवरेज ले लेंगे, तो वो उस दिन वो डेटा तो चला जाएगा ना सर, जितना नहीं हुआ है
हाँ,
रिकॉर्ड।
उसमें आपको, that is how when you have the data, first your aspect is the data cleaning. Suppose that if you have to see that how many days the, let us say the ATM was not working. Okay, तो वहाँ पे आपका आया कि what is the probability of the survival of the machine. तो 80% आपका काम कर रहा है, 90% मतलब कि 365 में से लेटर से 10 डेज काम नहीं कर रहा है मशीन। तो वो 10 डेज काम क्यों नहीं कर रहा है? दैट इज अनदर प्रोजेक्ट. What was the reason why there is the failure of the machine or the breakdown of the machine? मेंटेनेंस मशीन का हमेशा वो यूजुअली होता है उसका जो फेलियर, ये करेंसी फिलअप करते हैं उस टाइम पे, अदरवाइज मशीन चालू ही होता है। और टाइम जब
नहीं सर,
उनका, हाँ,
तो वही मेरा डाउट था कि अगर हम लिमिट सेट कर रहे हैं कि हमको 2 लाख रुपीज इसमें फिल करना है, लेकिन कस्टमर को रिक्वायरमेंट है, एक्चुअल रिक्वायरमेंट होगी 4 lakhs की, लेकिन हम उसमें 2 lakhs भर रहे, तो लेकिन हमारा जो एम है वो तो सेटिस्फाई नहीं हो पाएगा।
इसलिए तो
तो
डेटा क्लीनिंग करना है ना, फर्स्ट यू हैव टू क्लीन द डेटा, और जो
जी सर, वो
इंफॉर्मेशन आपके पास है उसके बेस पे मॉडल आपको बनाना है, ठीक है। और उसमें
ओके
से भी
सर,
आपको
ओके
ये जो मैंने बताया, दैट इज द एवरेज ट्रांजेक्शन विथ 95%। यू कैन ऑल्सो फाइंड आउट कि मैक्सिमम ट्रांजेक्शन कितना हो रहा है। सपोज मैक्सिमम ट्रांजेक्शन पर डे का हुआ, लेट अस से कि 3000 रुपीज, और 100 कस्टमर ऑन एवरेज आपके, उसमें भी आपको देखना है कि कितने पर रोज 100 आएंगे, ऐसा जरूर नहीं है। किसी दिन 98 आए, किसी दिन 105 आए, किसी दिन 55 आए। तो एवरेज नंबर ऑफ कस्टमर्स विजिटिंग दी एटीएम, और वो एटीएम जब विजिट करेंगे तब उसमें सक्सेसफुल ट्रांजेक्शन कितना है वो देखना है।
यस
जो
सर,
फेलियर ट्रांजेक्शन है उसकी बात नहीं करेंगे। तो वी हैव टू क्लीन द डेटा। जब एक बार डेटा आता है देन वी हैव टू हैव, जैसे आपने क्वेश्चन किया, जैसे ऑल पॉसिबल क्वेश्चन वी हैव टू आस्क, एंड देन वी हैव टू clean the data, and after cleaning whatever the data is we have, based on that we are suggesting.
यस सर,
Okay?
ओके सर,
और
ओके
उसमें
सर,
आपको जैसे आपने बताया कि 3 लाख का हो सकता है, तो हो सकता है दैट इज हाउ मैक्सिमम ट्रांजेक्शन आपका कितना है वो भी आप निकालें। जैसे हम मोड निकालते हैं ना, मोड इज नथिंग बट द मैक्सिमम ट्रांजेक्शन पर डे। तो आप वो
यस सर,
मोड निकालो। मोड आपका सपोज कि 3000 आया 2000 की जगह पे, क्योंकि एवरेज आपका 2000 है, मोड 3000 आया, 3000 मल्टीप्लाई बाय आप 100 करो, तो भाई 3 लाख तो आपको रखना पड़ेगा। तो कस्टमर की कोई तो आप 2 की जगह पे 3 लाख में जा सकते हैं। स्टिल यू कैन हैव द सर्वाइवल ऑफ द मनी। और आपको देखना है कि ऐसे पिक ट्रांजेक्शन कब हुए, कौन से टाइम में, कि सीजन वीक के जैसे सैलरी का टाइम होता है वो फर्स्ट वीक में या लास्ट वीक में, या फेस्टिवल सीजन में। तो आपको वो भी देखना है कि एज ए सीजनल यू टू आइडेंटिफाई कि सीजनल कितना पैसा आपको रखना चाहिए। जब सीजन का टाइम है तब मैक्सिमम लोग विड्रॉल करते हैं, तो 2 लाख की जगह पे 5 लाख, तो वो आपको सीजन की पैटर्न आइडेंटिफाई करनी पड़ेगी।
यस सर,
ओके, तो वंस वी हैव द डेटा, सिर्फ उन्होंने तो 1 साल का डेटा दे दिया। नाउ एज अ स्टैटिस्टिशियन वी हैव टू आइडेंटिफाई वेदर द वीक इज ए सीजन, वेदर द क्वार्टर इज ए सीजन, वेदर द मंथ इज ए सीजन। उस टाइम पे आपका कितना होना चाहिए, ठीक है। तो दैट वी
यस
कैन
सर,
ऑल्सो आइडेंटिफाई फ्रॉम द डेटा। दिस इज व्हाट आई हैव गिवन वन एग्जांपल, कि आप इस तरह से सोच सकते हैं। जैसे आपने दूसरा कहा वैसे आप दूसरी तरह से भी उसमें ऐड कर सकते हैं। तो दिस इज व्हाट आई एम एक्सपेक्टिंग, कि एज ए स्टैटिस्टिशियन वी शुड हैव द मेनी क्वेश्चंस इन आवर माइंड, एंड वी ट्राई टू आंसर द क्वेश्चन। मे बी आंसर आपका, सपोज आप क्वेश्चन आंसर हो रहे हैं या खुद के साथ आप डिस्कशन कर रहे हैं, गलत हो सकता है, डोंट वरी, बट कीप ऑन आस्किंग और कीप ऑन
यस
एनालाइजिंग
सर,
द डेटा। एक बार वो हैबिट हो गई तो जब भी आपको कहीं डेटा दिखा, आपके दिमाग में एनालिसिस चालू हो जाएगा। एंड जिसके दिमाग में ये होता है उसके लिए जॉब बड़ी कीमत, बड़ी चीज नहीं है। दे विल गेट द बेस्ट जॉब एट द बेस्ट प्लेस।
यस सर।
यस, एनी अदर्स, एनी क्वेश्चंस, एनीवन? दूसरा ये है कि अगर नहीं है तो मैं अपना जो पहला सेशन है जो मुझे एमएससी का शुरू करना है, वो मैं आपको, अपना लेक्चर कब तक है?
11:50.
11:50 ना? ओके, सो usually in distribution, whenever we are interested in finding the distribution of function of random variable, more precisely, some we have given the distribution of x1, x2, x3, xn, or let us say distribution of x. But if I am interested to find out some distribution of a function, let us say, as I say that random variable x has the Bernoulli trial, but what is the distribution of the sum of Bernoulli? How will you identify? Suppose the x has the Pareto distribution. What is the distribution of a log x? How will you identify? ये आपने पढ़ा है। तो आपने पढ़ा है कैसे, बेस्ड ऑन दी CDF, क्यूमुलेटिव डिस्ट्रीब्यूशन फंक्शन के बेस पे आप बात कर सकते हैं, या यू कैन फाइंड आउट द मोमेंट जनरेटिंग फंक्शंस। वहाँ पे मोमेंट जनरेटिंग फंक्शन ऑफ जो वेरिएबल है उसका आप निकाल सकते हैं, देन यू कैन फाइंड आउट द डिस्ट्रीब्यूशन। और थर्ड वन इज दैट यू कैन यूज द ट्रांसफॉर्मेशन ऑफ वेरिएबल। तो y is equal to log x, तो x इक्वल टू क्या हुआ, e raised to y. Find out the Jacobian and substitute in integration and find out the PDF of the transform variable. So there are mainly three techniques to obtain the distribution function of a variable or the sum function of a variables. One is based on the cumulative density distribution function technique. Second one is moment generating function techniques, and third one is a transformation of variables. So in second lecture we will start with the transformation of variables. जब हम नेक्स्ट लेक्चर में बात करते हैं तो आपको खास ध्यान रखना है कि आपके पास आपकी पेन और नोटबुक होनी चाहिए, क्योंकि मैं यहाँ पे आपको जैसे मैं बोर्ड में लिख रहा हूँ ना वैसे ही यहाँ पे स्क्रीन में लिखता जाऊंगा. वी विल सिस्टमेटिकली गो विद द थियरम एंड प्रूफ. हर चीज़ को डिस्कस करेंगे. मैं आपको होमवर्क भी दूंगा और वो होमवर्क का आपको टाइम भी दिया जाएगा. टाइम मतलब उसी टाइम में लेक्चर में कि भाई चलो 5 मिनट्स और 10 मिनट्स इज गिवन, व्हाट इज द आंसर. ठीक है. तो जैसे हम क्लासरूम में पढ़ाई करते हैं वैसे ही होगा, सिर्फ इतना है कि मैं आपको नहीं देख सकता, आप मुझे नहीं देख सकते. दैट्स ऑल. रेस्ट ऑफ द थिंग्स रिमेन दी सेम.
Okay, sir.
Any questions, any query to anyone else?